And the proofs that we've seen have just been equations. And so we know how to do and work through those proofs pretty easily because it goes back to Algebra 1, solving equations and doing some of those kind of things. Okay? But what we're going to be doing here is writing proofs that are more geometry in nature, where we're going to be doing something that we've done up to this point. But we're going to write a proof to kind of show us everything that's going on. Okay? And so we've worked through problems like this already this year, but now we're going to use a proof to kind of set it up and not only solve the equation itself, which is part of the problem, but then also provide reasonings as to why I can do what I'm doing. Okay? And that's kind of what geometry is all about. Being able to provide evidence or show proof of what we are doing. Okay? And we won't be doing proofs all year long, but this kind of is where we're at right now. So a proof is simply just a logical argument that just kind of describes what's taking place, and we do it kind of in an organized fashion. So if somebody were to look at this, they could kind of just follow the steps and have a better understanding of what's taking place. The most common proof that we're going to see, we might see some other types of proofs where we like write a paragraph and we call that a paragraph proof. But this is the one that we're going to use almost always, is a 2-column proof. We make 2 columns. The column on the left provides the statements. That's where we put in like the equations, or yesterday we did the UNO part of it. And then the reasonings goes on the right. Okay? And that would be the reasonings could be a property, a postulate, a theorem, a definition. There's a lot of different things that could go over here for the reasoning. Okay? And we talk about a lot of vocab and geometry. And so there's a lot of things that could be used. And sometimes some of those things that we're going to be using are things that we haven't used for quite a while. And so we got to kind of go back into our depth of knowledge and be able to pull those things out. All right, so as we've talked about when we write a proof, the first statement is going to be what? Given, right? And if you notice up here at the beginning, they tell us the given statement. Okay? So we're always going to label this step 1. T is the midpoint of SU. So that is given. Okay, what does that mean? If I tell you that T is the midpoint of SU, what does that mean to us?
It's in the middle of
Okay, so what would be a next statement for us if T is in the middle? Okay. So I'm going to say ST is equal to TU. Okay, then we have to identify a reason. Why do we know that ST and TU are the same? You're on the right track, okay? But remember, this over here is going to be a property, a postulate, a definition, a theorem, something along those lines. So what's something that we've talked about this year that we know that we can use here? How do I know that T is the halfway point?
solve 3x plus 20 and then 7x equals 3x.
Okay, that'll be our next step. Okay, but we got to identify a reason. Okay, we told you T is the midpoint, right? How do I know that that splits that segment?
Because the midpoint is equal.
You're on the right track. And what are you trying to explain to me?
What both sides equal.
Or what the midpoint is, right?
Yeah.
And so what we would say here is the definition midpoint. The reason we know that T is in the middle is because we know the midpoint splits a segment in half, right? And that's exactly what the definition of midpoint says. That's how we know that those two segments are the same. Okay? So sometimes it's as simple as that. But once again, just remember, when I provide a reason, it's a definition, a theorem, a postulate, something along those lines. Okay? We can't just say because. I know that T is the midpoint because. Or these two are because, right? It's got to be a proof. And so it's got to have something to back it up. Okay. So now, Hendricks, what did you think the next step was? You were saying it out.
With the equation,
Yeah?
that next equals 3x.
Okay, good. What have we done here? Why? What did we do to get from step 2 to step 3? Okay. Yeah, plugged it in. What's another word for plug it in or replace? Substitute, right? Did we do a property that used substitution? Substitution property. Okay. At this point, we have an equation written out. So now it's going to look very similar to what we did last week, where we're just going to solve these equations out, okay? And so now our goal, our final statement, kind of like we did yesterday with the UNO proofs, it tells me the proof statement. It tells me where I want to end up at. I want to end up at x equals 5, so I got to show the steps to get there. So now I got to solve this equation for x, right? It doesn't just come right out and say solve for x, but we know that we got to get to the point where it says x equals 5. So what would be our next step here? Ryan, what do you think? Subtract 3x. Good. Okay. And what you got to know here is that they're not going to show you that. They're not going to show you what's taking place here, right? They're not going to show you the minus 3x. But you got to know that that's what they did to both sides, right? And because we subtracted, this would be the subtraction property of equality. Okay? We know we're done when we get to this point right here. So we're not quite there yet. We got one more step to do, and what would that be? Divide by 4. So we get x equals 5. And we got there because we divided, so that's the division property of equality. Okay. So we got to the proof statement that we wanted, and we provided reasonings all the way down. Okay? Each statement has to have a reasoning. Okay? You can't have a statement without a reasoning right next to it. And that's why I always label both of them 1 and 1, 2 and 2, 3 and 3. So this is my statement, this is my reason. Okay? And so on. If I have 5 statements, I better have 5 reasons over there. Okay, so we've done the math. We've done things like that before, but now we're doing it with a proof. Not much to talk about on this one here. This is pretty much the same thing we talked about last week, except the difference is we're talking about it with congruence. Okay, we're talking about it with our congruence symbol. And so reflexive, we saw reflexive last week. Hendricks? Yeah. We saw reflexive last week. Reflexive means we have exactly the same thing on both sides. AB is congruent to AB. Last week it was with equality. Now it's with congruence. So everything we see here is going to be a congruent symbol when we do a property of congruence. Hey. All right, reflexive, we have the exact same thing, right?
Hey. I gave it to you.
Yeah. Thank you so much.
Here we go. Bye.
Bye. Symmetric property, remember it just flips sides. If I said that AB is congruent to CD, I can also say CD is congruent to AB, or I can do the same thing for angles. Angle A is congruent to angle B, B is congruent to A. Doesn't matter which way I write it, right? That's all the symmetric property says. If I say angle A is equal or congruent to angle B, then Xander could say angle B is congruent to angle A, and we're saying the same thing, okay? Transitive property, remember transitive takes two statements, puts them together, makes the third, okay? So here, they both are congruent to CD, so because they're congruent to CD, they're also congruent to each other, okay? The only difference from what this should look familiar, because we've already had all three of those properties before, but before we had it with equality, now we have it with congruency. So what symbol do we have in there? Okay, because we're talking about an actual angle or segment, we're not talking about the measure of it. We're talking about the actual segment or angle. Okay, now let's go to the proof sheet that we have here. Okay. I want you to try to write this one out, okay? Notice that these two say 2-5 notes, so these are part of our notes for today, okay? I want you to try to write this proof out based on the one that we did just a few minutes ago. See if you can do it. I'm going to do it as you guys do it, and then we're going to check it, okay? So try to write out a proof for this statement. Your final statement should be x equals 6. Should be able to almost follow exactly. Okay. Should look very similar to the one we did before, right? It tells me that C is the midpoint, so I'm just going to restate that as my step one. I'm going to say that these two segments are congruent. Okay. Sometimes it may just have this marked, okay? If these two are marked, that would also tell me that C is the midpoint. So from here on out, if they could tell me that C is the midpoint, or they could just put the markings on the picture, that tells me the same thing. Because those two pieces are congruent, then C must be the midpoint, okay? Those two mean the same thing. It doesn't always have to be a statement, but here we were provided the statement. Then we plugged in the two expressions, substitution, and then we subtracted 2x, so that would be subtraction, and then we divided by 2, which is division, okay? Everybody feel pretty good about that one? Okay. Now, number 2 gets a little tricky, okay? And this is where you're going to have to pay close attention to the problem itself, okay? I have the exact same picture on these two problems, okay? But we are not writing the same proof. So, here's the difference. Let's pretend like we haven't even done number 1. If I look at this picture and I ask you, is C the midpoint? What would you say? Could it be? Yeah? Do we know for sure? No. It would either need to tell me that C is the midpoint, or it would have to have markings here that C is the midpoint. Okay? We've said it over and over again, guys. Okay? And you got to keep reminding yourself of this. Just because C looks like it's in the middle doesn't mean that it is. Okay? Could it be in the middle? Maybe, but we can't just assume because we don't know for sure. Okay? So we got to be really, really careful about that. So I'm using the exact same picture, but my proof's going to look exactly different or completely different than the first one. Okay? So that's the big thing I want you to understand here and notice. We can only use the information that is provided to us in this particular problem. We're starting this problem all over again. So we're not using anything that we did on part 1 because this is a completely different problem, even though it has the same picture. Okay, so what does it tell me right here? 80 is 60, okay? So that is what we are given. So I'm just going to restate that, okay? The first step should usually be one of the easier steps. 80 is 60, given, right? And most of the time, your given statement will either be out here and say given, or it might be something labeled on here. Like it might be these two segments are congruent. It might be labeled on your picture. Okay? But here, if it says given, then we know pretty straightforward that it's a given statement. So that's pretty straightforward. Okay? Then we got to decide how we're going to use that piece of information. So I know the length of this to this is 60, okay? Not a bad idea to label that on your picture somehow, some way, to show that that is 60. So using what we know, how can we write another statement out? And remember, we're going to try to get to this statement right here. We want to get to the point where x equals 8 at the very end. Any ideas on what we could do next? Hannah?
AC plus CD equals 60.
Okay. And for right now, I'm just going to say AC plus CD equals 80. But you're on the right track, yes. I'm just going to name the segments, okay? This segment plus this segment equals the entire segment. What are we using there? Property, postulate, definition, theorem.
Property,
What kind of property?
substitution,
Not yet. We are adding. What are we adding? Okay, we're adding segments, right? So this is the segment addition postulate. Okay, we talked about it a little bit yesterday where that is a postulate that we have talked about. We talked about postulates a little bit yesterday. The segment addition postulate and the angle addition postulate are two postulates that we've talked about this year. Okay, it was a little bit ago, but we have talked about that. Okay, now, Cora, what do you think we could do?
Substitute.
Yeah, what are we going to substitute in?
4, 6, 4x.
Mhm.
2x plus
Okay. AC is really 4x because it's labeled up above. CD is really 2x plus 12. And Hannah had said it earlier, 60 is the length of the whole thing. Okay? So we're going to plug 60 in for 80. So everything has, it's something that it's replaced with. So when I take something and replace it with something else, we have substituted in to the equation. Okay. Once I have the equation set up, now it's just going right back to where we did last week. Okay? I want to get to the point where x is by itself, so our goal is to solve for x now. It doesn't just come right out and say solve for x, but that's what we're doing, okay? We're getting x by itself because that's what our proof statement says. So what would I do in this equation, first of all, to get x by itself? Good. 4x and 2x are on the same side as one another. 6x plus 12 equals 60. And here we simply say combine like terms. An easier way of saying that sometimes is you could just say simplify. We're trying to simplify the expression. Okay? Combine like terms is what we've heard for years now, going back to Algebra 1. But here we're simplifying or combining like terms. Either one of those would be acceptable here. Okay? And then all you're asking yourself is, what am I going to do next to solve for x? Darcy, what do you think I'd do next?
Substitute problem.
What would I do to solve for x next? What would be my next step?
Subtract.
Subtract 12. Okay. And I'm going to write it like it's going to be written to you guys. Okay. They're not going to actually show you that they're subtracting 12. Okay. We just have to know to get from here to here, we did subtract 12, right? So that would be the subtraction property. And then finally, Ethan, what do you think? What would we do to finish this thing up?
Divide out to 6.
Okay, good. So that would be the division property. Okay. And hopefully, when we're done, my answer matches up with our proof statement, right? If I got like x equals 5 down here, and this said x equals 8, uh-oh, something's wrong. Those have to match up, right? And the good news is they both say x equals 8, so we're in good shape. Okay. Your homework for today. There is no big ideas today, okay? Your homework for today are numbers 1, 2, 3, and 4 on your proofs packet, okay? So the next 2 pages, basically. Notice that the last page says 2 6 notes, so we're going to do those tomorrow, okay? 2 6 notes and 2 6 practice, so we haven't done those yet. So just 1, 2, 3, and 4 on pages 2 and 3 of that proof packet. Okay. Yeah. Okay. Some of those are similar to what we did. Some of them are a little bit different. Okay. But use your notes to kind of help you out on those.